Welcome to another episode of AI 10X brought to you by 10 Leaves. So, usually when we talk about a complex system, there's this expectation of absolute precision.
Right, like a computer network.
Exactly, or like a factory assembly line. You can map out every single input and output. You pull up a dashboard and see, oh, there's the bottleneck. It's clean, it's categorized, and it's totally visible.
Because it's completely deterministic. I mean, we really like systems where the variables are known and, controlled.
Yeah, but then you step into the world of urban transportation and, like, traffic flow, and suddenly that beautiful deterministic dashboard is just completely shattered.
Oh, yeah, completely.
We're looking at a landscape that is inherently chaotic. I mean, you are talking about millions of individual human decisions happening every single second on the asphalt, and they're constantly colliding with each other, usually based on, well, incomplete information.
Yeah, that's the reality of a daily commute.
Right? So welcome to the deep dive. Our mission today for you, the listener, is to explore the actual mechanics behind this fascinating overview we have. It's called Navigating the Future, AI and Autonomous Fleets and Traffic Control.
It's a great piece.
It is, and it points to one central, undeniable premise, which is that AI is, quite literally, taking the wheel in transportation.
Yeah.
But it's doing so in a way that fundamentally alters the physics of how a city moves.
What's fascinating here is that we are not just talking about a simple substitution of labor,
Like just swapping a human for a robot.
Exactly. This isn't just about taking a human out of the driver's seat and dropping an AI in to do the exact same job in the exact same way.
Right.
We are looking at a structural migration. We're moving from a world of isolated human-driven vehicles, which are essentially millions of disconnected reactive agents, to a fully integrated, smarter, and incredibly safer transportation ecosystem.
Okay, let's unpack this. Because when I hear the phrase, AI is taking the wheel, my immediate visual is incredibly localized.
Sure, most people think of their own car.
Yeah, I picture my personal car, but with an invisible chauffeur. Like, I'm sitting in the back seat, reading a book or checking my phone, while the steering wheel just turns itself.
Right, the luxury experience.
But the framework we are looking at today pivots entirely away from that individualistic image. We really have to ask what exactly the AI is driving, because it is not just a single car, right?
No, not at all.
The critical focus here is on autonomous fleets.
And that distinction is the entire foundation of this technological leap. I mean, a single self-driving car navigating a city of human drivers is an engineering marvel, obviously.
Oh, for sure.
But it is still just one isolated node trying to survive in a chaotic environment. An autonomous fleet, however, represents a total paradigm shift in data sharing.
Because they're talking to each other.
Exactly. These are self-driving vehicles specifically coordinated by an overarching AI. The key word there is coordinated. It implies a centralized network intelligence.
So they aren't just guessing what the car next to them is doing.
Right. These vehicles are not moving through the world blind to one another's intentions. They are in constant, seamless communication.
That makes me think of, like, an ant colony.
Oh, how so?
Well, imagine a single ant trying to find food. It's wandering around, bumping into things, hoping it finds something.
Yep.
It's kind of like a human driver or even a standalone self-driving car.
Right, reacting to immediate stimuli.
Yeah. But an entire colony communicating perfectly through chemical signals. They find the optimal path instantly. Or think about telecommunications. When I send an email, the data doesn't just wander around hoping to find the destination.
It gets routed optimally through the network.
Exactly.
Yeah.
Right now, human driving is like every single packet of data trying to figure out its own path in a total vacuum. We only know what we can see through the windshield. We literally guess our way through the world.
That's a really good analogy.
So the shift to a fleet is like moving to a master router. The AI is coordinating the entire swarm.
A telecommunications network is a perfect way to visualize it. And that swarm coordination unlocks massive systemic benefits. I mean, the most immediate one we have to look at is route optimization.
Right.
Think about how humans currently try to optimize a route. We use a navigation app, we look at the red lines on the map, and we choose the path that the app tells us is, 5 minutes faster.
But that creates its own problem.
Exactly.
Because if every single driver on the west side of the city sees that Main Street is the fastest route, and they all simultaneously decide to take Main Street.
Suddenly Main Street is completely paralyzed.
It's the tragedy of the commons, but for traffic.
Yeah, because humans act selfishly even when operating with the exact same data. We all want the absolute fastest route for ourselves, which, ironically, collectively creates gridlock.
Right. We defeat our own purpose.
But an AI-coordinated fleet doesn't operate on individual selfishness. It operates on mathematical load balancing.
Hmm.
It basically treats the city grid like a network of pipes.
Okay, so how does it decide who goes where?
Well, if it needs to move 10,000 vehicles from the north side to the downtown core, it doesn't send them all down the fastest highway. It calculates the exact capacity of every artery, every side street, and proactively distributes the vehicles across the available infrastructure.
Oh, wow. So it might intentionally take a slower route.
Exactly. It might route 20% of the fleet on a path that is technically 2 minutes slower, specifically to ensure that the primary highway doesn't reach a critical density threshold. It maintains this fluid equilibrium across the entire system.
So it's sacrificing the absolute optimization of one single car to ensure the holistic optimization of the entire fleet.
Precisely.
That fundamentally changes the math on commute times,
Yeah.
which leads directly into the secondary effect of this, right? A massive reduction in operational costs. And I want you, the listener, to really think about the mechanics of your daily drive. Just think about the energy wasted in a standard traffic jam.
It's unbelievable. The thermodynamic and economic footprint of human driving is incredibly wasteful.
Because we're terrible at maintaining speed.
We are. We are constantly accelerating too hard, braking too late, idling unnecessarily. I mean, every time you tap your brakes, you are converting forward momentum into useless heat energy.
Just burning money, basically.
Essentially, yes. But a perfectly coordinated fleet operates with absolute mechanical efficiency. They engage in something called platooning.
Platooning?
Yeah.
Like military platoons.
Kind of. It
Mhm.
means driving incredibly close together at high speeds because the communication latency between the vehicles is virtually zero.
Oh, so they can essentially draft off one another, like cyclists in the Tour de France, to reduce aerodynamic drag.
Exactly like that. The braking is smooth, the acceleration is synchronized across 20 vehicles simultaneously.
That's crazy to picture.
It is. And the reduction in electrical or fuel consumption, combined with the radically extended lifespan of physical components like brake pads and tires, represents a massive reduction in the cost per mile.
And all of that mechanical synchronization fundamentally rewrites the safety equation, too. I mean, humans are incredibly complex, but let's be honest, we are terrible drivers.
We really are.
We get tired. We have incredibly slow biological reaction times.
Yeah.
We get distracted by a billboard or, a text message. But a coordinated AI fleet just removes that biological lag.
Entirely.
Yeah.
Every single vehicle in that platoon knows exactly what the vehicle in front of it, behind it, and beside it is going to do milliseconds before the physical action even initiates.
Right.
The safety implications of removing human reaction time from a coordinated swarm are just staggering.
But here is the friction point in this vision. We can engineer a perfectly coordinated fleet of autonomous vehicles capable of incredible synchronization. But that fleet is ultimately handicapped if the environment it is forced to operate within remains rigid, dumb, and unresponsive.
Yes. A smart car operating on a fundamentally stupid road is a massive bottleneck.
Right,
Yeah.
because having a genius-level fleet of vehicles calculating aerodynamics and load balancing doesn't mean anything if they are forced to sit at a stubbornly timed red light for 3 minutes at 2 a.m. when there is absolutely zero cross traffic.
It's a completely inefficient use of space and time.
It drives me crazy.
Well, our current infrastructure relies heavily on static programming. Traffic lights largely operate on timed loops or perhaps basic inductive sensors buried in the asphalt.
So they don't really know what's happening.
No, they don't truly know what is waiting at the intersection, nor do they know what is coming. They only know when to change colors based on a rigid historical schedule.
It's like playing a song to a metronome. The metronome doesn't care if the band is rushing or dragging. It just keeps ticking at the exact same pace, completely blind to the reality of the music being played in the room.
That's a great way to put it. And if we connect this to the bigger picture, the transition is moving from that rigid metronome to dynamic real-time AI management.
So the city itself becomes smart.
Yes. We are talking about an AI system that is observing the entire city grid, analyzing the telemetry from the fleets, and actively molding the environment to accommodate the flow.
Okay, here's where it gets really interesting. But also, I kind of need to push back on the mechanics of this.
Yeah.
Because the overview states that AI traffic control actually predicts congestion and reduces delays in real time. How does predicting congestion actively reduce it?
Well, it's about preemptive action.
But it's easy to grasp an AI changing a light from red to green when it senses a car pulling up. That makes sense. But predicting a massive jam and preventing it. Are we talking about fluid dynamics here? How does an AI actively shape the flow of a city rather than just reacting to a backup that has already started?
Actually, fluid dynamics is a brilliant way to conceptualize it. Think of the city grid as a massive network of valves.
Okay, valves.
A reactive system waits for water to back up in a pipe, and then it opens a valve to relieve the pressure. That's what we have now. But a predictive AI system is constantly modeling the telemetry data of every vehicle.
So it sees everything all at once.
Yes, it aggregates real-time speed, trajectory, and volume data from the entire fleet. It doesn't just see the cars at the intersection. It sees the thousands of cars entering the highway 5 miles away.
Oh, so it's analyzing the system miles upstream.
Exactly. If the AI detects an anomaly, say an unusually large cluster of vehicles merging onto a northbound artery, it calculates that in exactly 14 minutes, that specific volume will hit a major downtown choke point.
And it doesn't just wait for them to get there.
No. Instead of waiting for that cluster to arrive and form a jam, the AI begins systematically altering the traffic light phases downstream right now.
Oh, wow.
It might elongate a green light by 3 seconds at one intersection and shorten a red light by 2 seconds at another. It actively flushes existing ambient traffic out of the target zone, essentially creating a pressure vacuum.
That is wild.
So by the time that massive cluster of cars arrives downtown 14 minutes later, the roads have been pre-cleared to handle the surge. The congestion was prevented before it ever materialized.
So what does this all mean for the listener? I mean, it means the death of the phantom traffic jam.
Yes, those are the worst.
You know the phenomenon. You're stuck on the highway for 20 minutes, crawling at 2 miles an hour. And when you finally get moving again, you look around for the accident or the construction, and there's absolutely nothing there.
Nothing at all.
It was just a ghost wave caused by one person tapping their brakes too hard an hour ago, causing a ripple effect that amplified backward through the traffic.
Exactly. And an AI traffic control system operating on predictive fluid dynamics acts as a dampener. It smooths out those ripples by adjusting the flow before the ripple can become a wave.
It is the ultimate systemic harmony. The autonomous fleets communicate their trajectories to the AI traffic control, and the AI traffic control continuously adjusts the physical constraints of the grid to facilitate those trajectories.
It is a constant real-time negotiation between the vehicles and the infrastructure.
Which sounds completely flawless.
On paper, yes.
Right. We have mathematically optimized fleets moving perfectly, and an all-seeing AI dynamically molding the city to ensure nobody ever stops moving. But if this mathematical equilibrium is so incredibly efficient, so demonstrably superior in terms of cost, time, and safety a count away,
I know where you're going with this.
why am I still sitting in bumper-to-bumper traffic on my way to the studio? Why haven't major cities fully automated their transport networks yet?
Because the physical world is incredibly stubborn, and it fiercely resists digital perfection. The material explicitly highlights that cities will automate transport gradually.
Very gradually.
And it points to 2 monumental roadblocks holding this vision back: physical infrastructure and legal regulation.
Let's dive into the infrastructure first, because this is the glaring gap between software potential and concrete reality.
It really is.
You can write the most elegant predictive machine learning algorithm in human history. But if the physical intersections, the streetlights, and the roads themselves don't have the hardware to communicate with that software, it is entirely useless.
The physical bottleneck is immense. For an AI to manage a city grid predictively, it requires vehicle-to-infrastructure, or V2I, communication.
Which means upgrading everything.
Literally everything. That means every single traffic light needs to be a node on a high-speed, low-latency network. They need advanced sensor arrays, edge computing capabilities to process telemetry data locally, and the bandwidth to handle millions of microtransactions of data per second.
And I want you to consider the reality of local municipalities. Just think about your own city. There is likely an intersection near you right now operating on a control box installed in 1995.
Oh, easily.
With fading bulbs and a pedestrian button that hasn't worked in a decade. Cities struggle to find the budget to fill potholes, let alone rip up entire metropolitan grids to embed millions of dollars in advanced sensory hardware into the asphalt.
Right. The financial capital required to upgrade a legacy grid into a smart grid capable of conversing with an AI fleet is astronomical.
It's just not going to happen overnight.
No. It is a staggering public works challenge. And it's not just financial, it's logistical.
Yeah.
You cannot shut down an entire city to install a new operating system. It has to be done piecemeal, intersection by intersection.
And even if we could, Like, even if we could somehow wave a magic wand, secure infinite funding, and upgrade every piece of hardware overnight, we immediately slam into the second, much more complex roadblock:
Regulation.
regulation. And this is where the conversation moves from engineering to liability, because our current legal code is entirely unequipped for this reality.
This raises an important question that legal scholars are currently wrestling with. Laws fundamentally rely on clear chains of accountability.
Who is in fault, basically?
Exactly. In our current paradigm, the liability matrix is incredibly simple. If a human driver runs a red light and causes an accident, the human is at fault. The insurance pays out based on human error.
Simple.
But introduce a fully automated AI fleet interacting with an AI-managed traffic grid, and that matrix shatters entirely.
Let's play out a hypothetical here, because the mechanics of this legal nightmare are really fascinating.
Go for it.
Okay, imagine an intersection managed by a municipal AI. A fleet vehicle approaches. The city AI calculates the flow and turns the light green for the fleet vehicle. But let's say a human driver, operating a legacy vehicle, blows through the red light on the cross street.
Okay, a common scenario.
Right. The fleet AI detects the human, calculates an evasive maneuver, swerves to avoid the fatal collision, but in doing so, crashes into a storefront. Who pays for the storefront?
See, the complexity of that single event is paralyzing for regulators.
Because there's no clear answer.
Exactly. Is the city municipality at fault because their traffic AI failed to account for the incoming human anomaly?
Or is the vehicle manufacturer at fault for the evasive algorithm?
Right. Is the software developer who wrote the fleet's load balancing code liable? Or is it entirely the fault of the unpredictable human driver who ran the red light in the first place?
And what if the city's sensor at the intersection experienced like a millisecond of latency and didn't transmit the human's trajectory in time? Now we are subpoenaing the hardware manufacturer of a sensor buried in the concrete.
It's an absolute nightmare. Regulatory bodies are inherently and rightfully risk-averse. They demand immense volumes of standardized testing, historical proof, and bureaucratic consensus before they allow experimental paradigms to govern public infrastructure.
Which takes years.
Decades sometimes. The legal frameworks literally have to be invented from scratch to accommodate a world where decentralized machine intelligence is making split-second, high-stakes decisions on public roads.
So the transition simply cannot be a global software update. It's going to be a grueling, gradual creep. We will see a geofence smart lane here, a connected intersection pilot program there.
Yes, a very fragmented rollout.
We are going to slowly build empirical trust while simultaneously rewriting the legal code line by line to figure out who is responsible when the math inevitably encounters chaos.
And that reality introduces the most dangerous phase of this entire evolution.
The hybrid period.
The hybrid period. We will not jump from a 100% human-driven world to a 100% AI-coordinated swarm overnight. For decades, we will exist in an uneasy middle ground. We will have hyper-intelligent, predictive, autonomous fleets forced to share the very same physical asphalt with easily distracted biological human drivers.
Which completely disrupts the optimization model we talked about earlier.
It throws a wrench in everything.
If the AI traffic control is trying to orchestrate a perfect fluid wave of movement, but 20% of the vehicles are humans who might suddenly brake because they dropped their phone, the AI has to constantly recalculate.
Exactly.
It's like trying to choreograph a complex mathematical ballet, but half the dancers on stage are just improvising their own routines.
The human element becomes the primary friction in the machine. But despite the massive hardware costs, the staggering legal complexity of liability, and the chaos of the hybrid phase, the ultimate trajectory is clear.
Yeah, the text is unequivocal in its conclusion. Transportation is undeniably moving toward this integrated future.
The momentum is just too strong. When you look at the raw data, the billions of dollars lost in mechanical wear and fuel inefficiency, combined with the safety implications of eliminating human reaction time, the systemic benefits are simply too massive for society to ignore.
We are slowly but surely migrating from a reactive, disconnected world to a proactive, coordinated ecosystem.
And what is truly compelling is that this physical integration of AI fleets and smart traffic grids is really just the foundational layer.
Oh, here we go.
The analysis ends with a rather provocative teaser regarding where this infrastructure goes next. It notes that the next major technological convergence to watch for is when this AI transportation network meets blockchain technology.
Wait, really? Blockchain. Now, that is a wild pivot. AI meeting blockchain in traffic control.
It seems disparate at first, but consider the sheer volume of data being exchanged.
Oh.
If you have millions of fleet vehicles, edge computing sensors, and municipal traffic AI systems constantly negotiating priority, exchanging telemetry, and rerouting based on load balancing.
You need a secure way to track all of that.
Exactly. You need an immutable, decentralized ledger. Blockchain could theoretically provide the trustless architecture necessary for these microtransactions of data to occur securely between competing fleet companies and city governments.
So, like, the Ford Fleet AI can trust the data coming from the municipal traffic AI without requiring a massive centralized human oversight committee to verify it all.
That's the idea.
Wow. Well, that is a deep dive for another day for sure. But as we wrap up today's exploration into the mechanics of autonomous fleets and predictive grids, we want to leave you with a final thought to mull over.
Consider this trajectory we've mapped out today. If we are genuinely progressing toward a future where AI flawlessly coordinates both the swarm of vehicles on the asphalt and the digital infrastructure guiding them, a holistic system designed for absolute mathematical efficiency, at what point does the human desire to manually drive become a luxury we can no longer afford?
That is a great point.
In a perfectly integrated predictive system, does the human driver simply become the ultimate congestion factor?
A profound question to take with you on your next commute. Thanks for joining us for another episode of AI 10X, brought to you by 10 Leaves. See you next time.